Hey guys, welcome back to Quick Code. Today we're doing another Brainstellar Quant puzzle. This one is called Break and Stick. It's a probability problem of medium type. You guys can pause and go over the problem. So we've been given a stick as represented over here, and we're gonna assume the length to be 1 for this problem. You can take the length to be anything you want, by the way. 1 is just a simple value. So this will be denoted as a length of 0, and this can be denoted as a length of 1, both ends of the stick. Now the stick drops and it breaks at a random point distributed uniformly across the length. This point over here, that it's distributed uniformly across the length, means that any value among the values 0 to 1, any value x between 0 to 1 is as equally likely as any other value, right? So we can denote the breaking point as for now p. Now p is a random variable which is uniformly distributed among the values 0 to 1, right? Now, if you notice that p is not the value that has been asked of us. What has been asked of us is the expected length of the smaller part. Now, this we'll be denoting by L, another random variable. Now, you'll have to notice that this L is somehow related to P. Now, how is that? For the values where P is less than 1 by 2, so in this bracket, P is basically the same as L. So L is equal to P. For when P is in the range of 0 all the way up to 1 by 2. For the other range, let's say P is from 1 by 2 to 1, L is basically 1 minus P. Now, why do I say that? Because if P is over here in this range, let's say P becomes something over here, then L is actually this value, because we're always going to consider the smaller part. So now we're not going to be considering this length, but actually this length, right? Now, as we just said, that P is a random variable, a uniform continuous random variable distributed between 0 and 1. That would mean that L, where its maximum values can be 0 all the way up to 1 by 2, right? Because L can never be more than half, because in that case, 1 minus L will actually be the proper smaller part. So L can only be between these two values. Now, there's two solutions I'm going to talk about. The first solution notices the fact that, so for the range 0 to 1 by 2, L is equally likely to have any value between them. And now for the values 1 by 2 to 1, I'm talking about the P values. So for the values from P of being 1 by 2 to 1, L has an exact identical mapping as over here. So L has an equally likely chance of being a value over here, or over here, or over here, or over here. And for P being among these values, we just map them to these values, right? We just mirror them. So what happens is now L has twice enough the chance of being this value, twice the chance of being this value, twice the chance of being this value. But what's important to notice is that the probability of L between 0 and 1 by 2, any one value between 0 and 1 by 2, has become doubled. And if it's double for each and every value, and it's double just because for a value over here, it's going to correspond to the value over here, right? Since each of these values are doubled, then we can say that L is still a continuous uniform distribution, because any value between 0 all the way to 1 by 2 is still equally likely. And since L can be noted as a uniform distribution, the expected value of L is just, well, if I call this A and call this B, then by the formula of the expected value for a uniform distribution, it's B minus A over 2, which in this case becomes 1 by 4. Now, another way of thinking about this is to take two cases. Take these two cases over here. Well, now, considering these, I could say that for the expected value of L, well, there's a 1 by 2 probability that this case hits, where P is among the first half, right? And there's a 1 by 2 probability that the other case hits, where P is among 1 by 2 to 1, right? And now the expected value of L for this case, or actually this case, where P lies between 0 and 1 by 2, would be the half of this, right? And which would be 1 by 4. So over here, we plug in 1 by 4. Now for the other half, which would be looking something like this, where P can go from 1 by 2 all the way up to 1. what is the expected value of the length of the smaller part? It's going to be 1 by 4 again. So we add a 1 by 4 over here too. And this sum comes up to be the exact same value of E of L being equal to 1 by 4. I hope you guys understood both the solutions. I recommend you guys to pause and try to think about the logic. And thanks for watching.